Welcome to the lecture on Basics of Rolling Processes. Basics of Rolling Processes. In this talk the following topics will be discussed. Applications of rolling processes. Principle of rolling process. Types of rolling processes. Types of rolling mills. Defects in rolled parts. Applications of rolling process. Rolling is one of the important metal forming processes used to produce various products including sheets and plates. Rolling process is used to convert metal ingots to stock members like blooms, billets, slabs, structural members, sheets, plates, bars, rods, coils, etc. What is ingot? Ingot is a semi-finished solid metal block produced in a non-continuous casting process by pouring liquid metal into large molds. Then, ingots are rolled into blooms, billets and slabs. What is slab? Slab has a rectangular cross-section with thickness normally in the range of 150 mm to 350 mm. The width of the slab is greater than 500 mm and the usual width to thickness ratio is at least 3 to 4. What is bloom? Bloom has a square or rectangular cross-section. Each side of the bloom is having a dimension which is greater than 150 mm, but less than 500 mm. The width to thickness ratio is always less than 2. Blooms are used to produce structural beams like rails. What is billet? Billet has a square cross-section and smaller in size, compared to a bloom. Each side of the billet is having a dimension which is less than or equal to 150 mm. The length of the continuous cast slab or bloom, or billet can be cut as per requirement. Rods and bars are solid metal parts produced generally from billets using rolling processes. Further applications of rolling processes include seamless tubes and pipes, seamless rings, threaded rods, gears, rails, structural sections, balls, formed sections. Plate cylinders, bent tubes. What is rolling process? Rolling is a metal forming process in which metal stock is passed through rolls to reduce the thickness or change the cross-section of the stock. Working principle of rolling process. Rolling works on same as any other metal forming processes. When a compressive force applied by a set of rolls on ingot or any other product like blooms or billets, plastic deformation takes place which decrease its cross-section area and convert it into required shape. Types of rolling processes. Based on the geometry of the products, rolling processes are the following types: flat rolling, profile rolling, ring rolling, thread rolling, Tube piercing. Roll bending of plates and tubes. Transverse rolling or roll forging. Skew rolling. Flat rolling. This is the most basic form of rolling in which the starting and end material both have a rectangular cross-section. The gap between the two rolls is less than the thickness of the starting material, which causes the deformity of it. In flat rolling, the material, which is pushed through due to the friction at the interface between the material and the rolls. Flat rolling of slabs, blooms and billets. Since the introduction of continuous casting process, production of uninterrupted lengths of slabs, blooms and billets evolved. Here, flat rolling process is employed. Profile rolling. Rolling process in which the workpiece passes through a series of rollers that gradually shapes the workpiece into the required profile. Ring rolling. Ring rolling is a particular category of metal rolling, in which a ring of smaller diameter is rolled into a precise ring of larger diameter and a reduced cross-section. Thread rolling. The thread rolling is a cold forming type of rolling process used to cut threads on a cylindrical blank. The cylindrical blank passes through the threaded rolls, which displace the material and form threads on the cylindrical blank. Tube piercing. Tube rolling or hot piercing, or seamless tubing process is a hot forming process that can manufacture long lengths of seamless tube and pipe. In this process, a cylindrical rod is centered drilled at end and pierced using a stationary mandrel to form cavity due to tensile stress in a cylindrical rod when subjected to external compressive stresses. This process is used to making seamless hollow tubes. Roll bending of plate. In roll bending of plate, the plate passes over a lower roll pair while being pressed by an upper roller which forces the plate to bend. Roll bending of tube. In roll bending of tube process, larger tubes are fed past contoured pressure rollers resulting in a continuous bend. Transverse rolling or roll forging. In roll forging process, the workpiece is fed through two specially shaped rolls to create a long product with varying cross section. The transverse rolling processes are used to roll shapes on cylindrical components. In this operation, the cross section of a round bar is shaped by passing it through a pair of rolls with profiled grooves. Skew rolling. Skew rolling is typically used for making ball bearings. In this process, round wire or bar is fed directly into specially designed rollers which continuously form spherical balls by rolling action. What is rolling mill? A rolling mill is a machine in which a metal forming process takes place by passing the stock through massive pair of rolls. The term rolling is categorized by the temperature at which the metal gets rolled. Hot rolling is carried out above the recrystallization temperature, whereas cold rolling carried out below recrystallization temperature. A simple manual rolling mill looks as in the picture. Here, rolls can be changed, and gap between rolls can be adjusted. Types of rolling mills. Rolling mills are classified based on the number and arrangement of the rolls in it. These include 2-high rolling mill, 3-high rolling mill, 4-high rolling mill, tandem rolling mill, cluster rolling mill, planetary rolling mill. Two-high rolling mill. 2-high rolling mill has 2 rollers arranged as in figure. The space between the rollers can be adjusted by raising or lowering the upper roll, which is adjustable. Typical 2-high rolling mill is shown here. Three-high rolling mill. 3-high rolling mill has 3 rollers arranged as in the figure. These types of rolling mills are used for rolling of continuous passes in a rolling sequence without reversing the drives. This results in a higher rate of production than the 2-high rolling mill. Four-high rolling mill. A 4-high mill has 4 rolls, 2 small and 2 large. The 2 rolls which are in direct contact with the workpiece are smaller in size and called working rolls. Backup rolls are used to prevent the deflection of the smaller rolls. Different parts in a 4-high rolling mill are shown in figure. Tandem rolling mill. Tandem rolling mill consists of a number of non-reversing 2-high rolling mills arranged one after the other, so that the material can be passed through all of them in a sequence. In this method, rolling is done in one pass. Cluster rolling mill. In cluster rolling mill, each working roll is backed up by 2 or more larger backup rolls. These rolls are arranged as shown in figure. Cluster rolling mill is built based on Sensimi technology. This technology is known worldwide for its ability to roll extremely hard materials to very thin gauges. Arrangement of rollers in a Sensimi mill is shown in the photograph. Planetary rolling mill. Planetary rolling mill has a large backup roller which is surrounded by many planetary working rolls. Each planetary roll gives constant reduction. It is used to reduce large thickness of the steel strip in a single pass. Defects of rolling processes. The rolling defects are mainly 2 types. Surface rolling defects and internal structural rolling defects. Surface defects include impurities and inclusions in the material surface, roll marks, dirt, rust, etc. The internal structural defects are wavy edges, warping, zipper cracks, center wrinkling, edge cracking, center splitting, alligatoring. What is roll deflection? During the rolling process, due to higher forces, rolls tend to deflect from original axis of rotation. This can lead to variation in thickness and other defects in products. Roll camber or crowned roll. To overcome the variations in the sheet thickness, rolls are ground so that they are thicker towards the center. This extra thickness is called the camber. A roll with a camber is also called a crowned roll. Deflection in cylindrical roll. Cylindrical roll that does not have a crown causes the roll surface at the nip to become very slightly concave. Straight roll surface in crowned roll. Roll with the correct crown will cause a roll surface at the nip to become perfectly straight. Insufficient camber. Insufficient camber makes the rolled sheet thicker towards center and thinner at edges as shown in the figure. This induces residual stresses of compression at the edges and tension along the center line of the workpiece. Wavy edges, warping, zipper cracks. The uneven distribution of stresses leads to waviness along edges, zipper cracks along the center, and warping as shown. Overcambering. Overcambering is the condition when the rolls are given a larger convex curvature than the desired. This causes a sheet to thinner at the center than at the edges. This is the reverse of the undercambered situation and hence the tensile forces are more at the edges and the compressive forces are at the center. Center wrinkling. Overcambering leads to center wrinkling, edge cracking, center splitting. Center wrinkling is due to the high compressive forces at the center, which leads to the condition of wrinkling at the center because of excess compression. Edge cracking and center splitting. Edge cracking is due to the high tensile forces along the edge portion. This causes the material at the edges to yield before the actual yield point and hence causes cracking as a result of failure. Center splitting is a severe case of the edge cracking. Since the center is under a much higher compressive force, the resulting friction at the center can lead to splitting of the metal sheet along the center. Alligatoring. The formed sheet metal will adhere to the rolled surface and to follow the path of their respective rolls, the sheet will shear in the plane, and this defect is called as alligatoring. Here, rupture of the material along the length into an upper half and a lower half resembles the open mouth of an alligator.